You're standing in the middle of a thriving city, but something feels fundamentally wrong in a way you can't immediately identify. The buildings around you rise dozens of stories into the air, their surfaces smooth and organic, shaped from materials that seem to grow rather than be assembled. There are no steel beams visible through construction sites, no iron railings along balconies, no copper wires strung between poles. The vehicles moving through the streets are silent and strange, their frames constructed from compressed plant fibers and ceramics, their wheels wrapped in rubber, harvested from trees, but reinforced with materials you don't recognize. You reach into your pocket instinctively, expecting to feel the familiar weight of keys or coins, but there's nothing there, because in this world, locks work on entirely different principles, and currency has never been minted from metal. You look down at your hands and realize you're holding a tool, something like a knife, but made from obsidian, its edge sharper than any steel blade could ever be, but also more fragile, requiring constant care and attention. This is Earth, recognizable but alien, a planet where the periodic table took a different path, where iron and copper and aluminum and gold never formed in the cosmic processes that created our world. This is a civilization built entirely without metal, and understanding how we got here requires reimagining almost everything about human technological development. Because the absence of metal doesn't just change what we build with, it changes what kinds of societies we can create, what kinds of thoughts we can think, what kinds of futures we can imagine. Let's walk through this strange, familiar world and discover what humanity becomes when the foundation of every civilization we've ever known simply doesn't exist. To understand what we've lost, we need to appreciate what metal actually is and why it's been so central to human advancement. Metals are elements whose atoms arrange themselves in crystalline structures where electrons can move freely, creating materials that are simultaneously strong, malleable, and conductive. This unique combination of properties has made metals irreplaceable in human technology. Iron can be heated and hammered into shapes that retain their strength. Copper conducts electricity with minimal resistance. Gold resists corrosion while remaining soft enough to work into intricate forms. The Bronze Age, the Iron Age, the Industrial Revolution, the Digital Age, every major leap in human civilization has been enabled by our mastery of different metals and their alloys. Remove metals from Earth's geology entirely, and you remove the entire ladder that humanity climbed from Stone Age tribes to spacefaring civilization. But nature abhors a vacuum, and human ingenuity is relentless. So in our metalless world, alternative materials and technologies would have evolved to fill some of the gaps, though not all, and never perfectly. The first and most obvious question is whether complex life could even evolve on a metalless Earth, because metals play crucial roles in biological chemistry. Iron sits at the heart of hemoglobin, the molecule that carries oxygen in your blood right now. Magnesium is essential to chlorophyll, the molecule that allows plants to capture sunlight and produce the oxygen you breathe. Zinc, copper, manganese, dozens of metal ions serve as catalysts in the enzymes that make life's chemical reactions possible at biological speeds. A planet completely devoid of metals probably couldn't support life as we know it. So let's refine our scenario. Earth has trace amounts of metals, enough for biology to function, but no concentrated ore deposits, no veins of copper or iron that ancient humans could mine and smelt. The metals exist only in dispersed forms, locked in minerals at concentrations too low to be economically extracted with anything less than modern industrial chemistry. This gives us a biologically viable planet where humans evolve normally, but where the technological path to civilization must take a completely different route because the stepping stones we actually used simply aren't available. Early humans in this world would develop stone tools exactly as our ancestors did, because stone requires no special processing beyond finding the right rocks and learning to nap them into useful shapes. Obsidian, flint, and other hard stones would be prized for their ability to hold incredibly sharp edges, sharper than steel actually, though vastly more brittle. But here's where the divergence begins. In our history, the discovery of copper smelting around 7,000 years ago enabled tools that were superior to stone in almost every way, soft enough to be shaped, but hard enough to be useful, and crucially, repairable when damaged. A broken metal tool can be melted down and reforged. A broken stone tool is just garbage. This repairability accelerated technological development because craftspeople could experiment and fail without completely losing their investment in materials and labor. Without metal, tool making remains stuck at the stone level for much longer. Progress measured in millennia rather than centuries, because every failed experiment means starting over from scratch. But humans are nothing if not creative under constraint, and faced with the limitations of stone, our metal-less civilization would have pushed other materials far beyond what we managed in our timeline. Wood technology would advance to levels we never explored because we never needed to. In our world, wood is a construction material and a fuel source, useful, but quickly superseded by superior alternatives. In the metal-less world, wood becomes the primary structural material for everything from buildings to vehicles to machinery, which means developing sophisticated understanding of different wood properties, creating lamination techniques that glue thin layers together to create materials stronger than any single piece of timber, discovering chemical treatments that make wood resistant to rot and fire and insects. Bamboo, which grows faster than almost any other plant and has a higher tensile strength than many metals, becomes extraordinarily valuable. Entire economies built around bamboo cultivation and processing. Tropical regions with access to bamboo would have enormous advantages over temperate zones, potentially shifting the geographic centers of civilization away from the river valleys of Mesopotamia and China that dominated our actual history. Stone itself would be understood and utilized at levels of sophistication we never achieved. The Inca built structures from precisely fitted stone blocks without mortar, each stone ground to fit its neighbors so perfectly that you can't slide a knife blade between them. In our world, this technique was abandoned once better alternatives appeared, but in a metal-less world, it would be refined and perfected over thousands of years. Imagine cities built from interlocking stone components, each piece custom-shaped to fit into the whole, the entire structure gaining strength from the precision of its fitting rather than from any binding material. The labor requirements would be enormous, each building taking decades to construct, but the results would last millennia. Structures so solid and well integrated that they could withstand earthquakes that would destroy anything built with mortar or modern techniques. Architecture would necessarily be heavier and more massive than in our world, because without steel reinforcement, buildings can't achieve the same height-to-weight ratios, but they would also be more permanent. Civilizations measured by structures that genuinely last forever, rather than the century or two we consider impressive today. Ceramics and glass would become far more important than in our timeline because they offer properties that neither stone nor wood can provide. Ceramics can be molded into complex shapes, can withstand high temperatures, can be made waterproof and chemically resistant. In our world, ceramics are mostly relegated to pottery and specialized industrial applications. But in a metalless world, advanced ceramics would serve roles currently filled by metals. Cutting tools would be made from ceramic materials similar to the modern industrial ceramics used in machining, harder than steel, but requiring completely different manufacturing processes. Glass, which in our world is mostly used for windows and containers, would be developed into a structural material. Techniques for creating glass fibers and weaving them into composites that combine the transparency of glass with the flexibility of fabric. Buildings would have walls of glass composite, translucent structures that allow light to penetrate deep into interiors, creating architecture that feels fundamentally different from either stone or steel construction. But here's where we encounter the first truly insurmountable barrier. Agriculture at scale becomes far more difficult without metal tools. Plows are one of humanity's most important inventions, devices that break up soil and allow systematic cultivation of large areas. The earliest plows were wood, but they only worked in soft soils and broke frequently. Metal plowshares made agriculture efficient enough to support cities and specialization of labor. Without metal, plows remain wooden or stone-tipped, less effective and requiring more maintenance, which means agriculture remains more labor-intensive. This has cascading effects on civilization development. If more people need to work in farming to produce the same amount of food, fewer people are available for specialization into craftspeople, scholars, artists, soldiers. Cities stay smaller, states remain less centralized, technological progress slows because there are fewer people with the leisure to experiment and innovate. The metalless civilization might spend several thousand additional years at a population level and social complexity equivalent to ancient Egypt or Rome, not because people are less intelligent or creative, but because the economic surplus necessary to support large specialized populations simply takes longer to generate. Warfare in this world would look bizarrely different, and paradoxically, might be less devastating than in our timeline. Without metal, armor becomes much less effective. You can make armor from hardened leather, from ceramic plates, from tightly woven plant fibers, but none of these provide the protection that steel plate armor offers. Similarly, weapons remain stone-tipped spears and arrows, wooden clubs, ceramic knives. These can certainly kill. Humans are fragile regardless of what technology we have, but the lethality at range is much more limited. An arrow with a stone point is deadly at close range, but loses effectiveness beyond 50 or 60 yards. A metal-tipped arrow remains lethal at twice that distance. This changes tactics fundamentally, making warfare more about close-quarters combat and less about ranged killing. Defensive fortifications become more important because without effective siege engines, which require metal components for tensioning and pivoting, attacking a well-defended stone wall becomes nearly impossible. Wars might be less frequent and less decisive because the costs of attacking fortified positions are prohibitively high, leading to longer periods of stalemate and more emphasis on diplomacy and trade rather than conquest. The great empires of our history, Rome and Mongolia and Britain, built their power largely on superior metallurgy that allowed them to field better equipped armies. Without that advantage to exploit, maybe history becomes more multipolar, more fragmented, without the great unifying empires that spread technology and culture across continents. Transportation faces severe limits in a metalless world because wheels need axles, and axles need to rotate with minimal friction. And achieving low friction without metal bearings is extraordinarily difficult. Wooden axles and wooden wheels work. This is how the earliest vehicles functioned, but they wear down quickly and can't support heavy loads or high speeds. Stone bearings are possible, but expensive and still wear down faster than metal. This means wheeled vehicles remain less common and less useful, which in turn means roads develop more slowly and trade routes are more limited. River and ocean transport become even more dominant than in our history because water naturally reduces friction, making it possible to move large loads without requiring sophisticated bearing technology. Boats would be constructed from wood, treated and laminated to resist water damage, or from plant fiber composites similar to fiberglass. Vessels that could be quite large and seaworthy, but would require more maintenance than metal-hulled ships. Navigation would depend on celestial observation and dead reckoning, because magnetic compasses require metal needles, a technology that simply doesn't exist in this world. This makes long-distance ocean voyages more dangerous and less reliable, potentially delaying the age of exploration and keeping civilizations more isolated from each other for longer periods. The really fascinating question is whether industrialization could happen at all in a metalless world. Because the Industrial Revolution, as we experienced it, was fundamentally about metal. Machines made from iron and steel, powered by coal and later petroleum, performing work that human or animal muscle couldn't match. The steam engine, the foundational technology of industrialization, requires metal to contain high-pressure steam, metal pistons, and cylinders that can move with minimal friction, metal boilers that can withstand heat and pressure without failing. Could you build an equivalent device from non-metal materials? Maybe, but it would be exponentially more difficult. High-pressure steam engines are probably impossible without metal, but low-pressure steam engines might be achievable using ceramic components, though they would be far less efficient and far more prone to catastrophic failure. This means the power density of engines in the metalless world would always be much lower than what we achieved, which in turn means that certain applications become impractical. You probably can't build steam-powered trains or ships without metal, because the engines required to move heavy loads at useful speeds need pressures and temperatures that non-metal materials can't reliably handle. But here's where the alternate timeline gets really interesting. Faced with the limitations of heat engines, metal-less civilization might develop completely different power sources. Water and wind power would be pushed to extremes we never explored because we found easier alternatives. Imagine windmills engineered to extraordinary levels of sophistication, their blades made from laminated wood or fiber composites, their gearing systems using ceramic bearings and careful lubrication, achieving efficiencies we never attempted because steam power was more convenient. Hydroelectric power might actually develop earlier in this timeline because generating electricity doesn't necessarily require metal the way steam engines do. Water wheels can be constructed from wood and stone, and while electrical generation requires conductive materials. Some metal-free alternatives might work. Carbon, in various forms, can conduct electricity, and in a civilization desperate for alternatives, techniques for creating high-conductivity carbon materials might be discovered centuries earlier than in our timeline, driven by necessity rather than scientific curiosity. Which brings us to electricity, one of the most transformative technologies in human history, and one that seems fundamentally dependent on metals. Copper wire is the standard for conducting electricity because copper combines high conductivity with reasonable cost and easy workability. Without copper, can you have electrical technology at all? The answer is yes, but it's harder and less efficient. Carbon nanotubes, which weren't discovered in our timeline until the late 20th century, can conduct electricity as well as, or better than copper, and they're made entirely from carbon, no metals required. In a metal-less civilization, facing the immense obstacles to mechanical industrialization, the incentive to develop alternative electrical conductors would be enormous. Perhaps a metal-less humanity discovers carbon nanotube production in the equivalent of their 19th century, centuries earlier than we did, because they need it desperately rather than treating it as an interesting curiosity. With carbon-based conductors, electrical motors and generators become possible, opening a path to industrialization that bypasses steam power entirely. The metal-less industrial revolution might be electrical from the start. Cities powered by hydroelectric dams and wind farms, vehicles driven by electric motors rather than internal combustion engines, a civilization that looks more like our imagined green future than our actual industrial past. Computing would follow a completely different trajectory because the entire history of computing in our world is a history of metal technologies. Early mechanical computers used metal gears and levers. Vacuum tubes required metal electrodes and housings. Transistors are made from silicon, but require metal contacts and interconnects. Modern computer chips are built on silicon wafers, but use copper interconnects and aluminum or gold bonding wires. Remove metals, and you need to rethink computing from first principles. But here's an amazing possibility. Biological computing might develop much earlier in a metal-less world. Our brains are proof that complex computation doesn't require metal. Neurons are biological cells that process information using chemical signals and electrical potentials maintained by ion gradients across cell membranes. A civilization that can't build electronic computers but understands biological systems might develop computing platforms based on engineered neurons or other biological information processing systems. Computers that are grown rather than manufactured, that use chemical signals instead of electrical currents, that operate on principles we're only beginning to explore in our timeline. The processing speeds might be slower than silicon chips, but the parallel processing capabilities could be extraordinary. Massive biological neural networks capable of pattern recognition and learning that silicon still struggles to match. Medical technology would face severe challenges, but might also find innovative solutions. Surgery without metal instruments is certainly possible. Obsidian scalpels are actually sharper than steel surgical blades, but the absence of metal creates problems for more complex procedures. You can't make artificial joints from ceramics alone because they would fracture under the repeated stress of movement. You can't make pacemakers or other implanted electrical devices without conductive materials. But maybe metal-less medicine goes in completely different directions, becoming far more biological and less mechanical than ours. If you can't replace a joint with metal, perhaps you develop techniques for regrowing cartilage or even entire joint structures using the patient's own cells. Regenerative medicine becoming the primary approach rather than the cutting-edge experimental technique it is in our world. Without metal surgical tools, maybe surgery remains more limited, but is supplemented by pharmaceutical approaches we never fully developed. Chemical treatments that can accomplish internally what surgery does externally. Dissolving kidney stones instead of removing them. Using drugs to reshape blood vessels instead of installing metal stents. The aesthetics of a metalless civilization would be hauntingly beautiful and completely alien to our eyes. We're so accustomed to metal, to its shine and its hardness and its permanence, that imagining a world without it feels like something is missing. But the metal-less civilization wouldn't experience that absence. They would have developed aesthetic sensibilities around the materials they do have, finding beauty in the grain of laminated wood, in the translucence of glass composites, in the organic curves that ceramic materials naturally form. Their cities would feel more grown than built, structures that echo natural forms, because the materials and construction techniques favor curves and distribution of stress over straight lines and concentrated loads. Buildings would be covered in living plants not just as decoration, but as functional components, vines and mosses and trees integrated into structures to provide insulation, to filter air and water, to stabilize the underlying materials. The boundary between architecture and ecology would be far more fluid. Cities that feel like forests, artificial and natural elements so intertwined that separating them becomes meaningless. Art and culture would be shaped by the materials available and the constraints they impose. Sculpture would favor stone and ceramic, artists working within the limitations and possibilities of these materials, creating works that might emphasize mass and permanence rather than delicacy. Jewelry would use glass, ceramics, and organic materials like shells and polished stones rather than metal, developing aesthetic traditions around these alternatives that we would find strange, but which would be completely normal to them. Music would sound different because musical instruments would be built from available materials. String instruments with ceramic or glass resonating chambers. Wind instruments carved from wood or bone. Percussion instruments from ceramics and stretched hide. The timbres and tones would be unique, a musical landscape that has no equivalent in our world. Scales and harmonies that developed independently because the physics of their instruments led them in different directions than ours did. Currency and economy would function completely differently without metal coins, because coinage has been central to economic development throughout our history. Metal coins work because metal is durable, divisible, and hard to counterfeit. You can carry your wealth as physical objects that retain value over time. Without metal, money needs to be based on other principles. Maybe currency remains largely barter-based much longer into history, or maybe paper money and banking develop much earlier out of necessity, written certificates representing stored value becoming the norm because physical currency is impractical. Ceramics could serve as money, carefully crafted tokens of standardized weight and design, but they're fragile, every transaction carrying the risk of breaking your money. This might make economy more conservative, less liquid, people less willing to engage in speculative ventures, because the friction costs of every transaction are higher. Or maybe it drives innovation in other directions, credit and debt systems becoming more sophisticated earlier, reputation and trust becoming more formalized because they're the only reliable basis for economic interaction when physical currency is problematic. Space exploration in a metal-less civilization would be either completely impossible or so delayed that it becomes a project for the far future. Rockets require metal in almost every component, from the combustion chamber that withstands extreme temperatures and pressures, to the fuel tanks that hold cryogenic liquids, to the structural elements that support massive loads during launch. You might be able to build a rocket from advanced ceramics and composite materials, but the engineering challenges would be extraordinary, and the failure rates would be high enough to make programs economically unfeasible. This civilization might remain earthbound much longer than we have, or they might develop completely alternative approaches to space access. Electromagnetic launchers that accelerate payloads along a track could be built largely from non-metal materials, though achieving the necessary speeds would require solving massive engineering problems. Or maybe they focus on atmospheric systems first, developing high-altitude balloons and airships to extreme sophistication before attempting spaceflight, gradually pushing the boundary between atmosphere and space until eventually they develop techniques to cross it. The question of whether this civilization ever catches up to our level of technology is genuinely uncertain. They start from the same evolutionary baseline, humans with the same cognitive capabilities and the same drive to understand and control their environment. But technology isn't just about intelligence. It's about what possibilities the physical world offers. And a world without accessible metal ore deposits offers fewer easy paths to advancement. Every technology takes longer to develop, requires more ingenuity, more trial and error, more time. The civilization might reach something equivalent to our medieval period and then stall for centuries or millennia, unable to find the next ladder rung, trapped at a complexity level that can't generate the surplus needed to push further. Or maybe forced to think differently about every problem because they can't use the metal-based solutions we employed, they discover approaches we never considered, creating technologies that are genuinely superior in some ways to what we built. Perhaps their bio-integrated architecture is more sustainable than ours. Perhaps their biological computing ultimately proves more powerful for certain applications than silicon chips. Perhaps being forced to work within ecological limits rather than exploiting non-renewable resources makes their civilization more stable and longer lasting than ours has proven to be. And here's the philosophical heart of this thought experiment. To what extent is our civilization, with all its achievements and flaws, determined by the material resources we happen to have available? We like to think that human ingenuity is the key variable, that given time, we would have figured out how to accomplish anything regardless of starting conditions. But walking through this metal-less world suggests that materials matter profoundly, that the path of technological development is shaped by what's physically possible with available resources, and that different starting conditions lead to genuinely different civilizations, not just ours. With a few details changed, but fundamentally distinct ways of organizing society and interacting with the physical world, we are, in some deep sense, the civilization that metal made possible. Our cities, and our wars, and our electronics, and our economies all reflecting the properties of the materials we learned to extract and shape. In a world without metal, humanity would still be recognizably human, still creative and ambitious and curious, but the civilization we would build would be so different that a member of that world dropped into ours would feel like they'd traveled not just to another place, but to another universe entirely, where the basic rules of what's possible have changed. So we return to that strange city where we began, walking streets paved with ceramic tiles that have lasted centuries, past buildings grown as much as constructed, their walls living structures of wood and vine and carefully shaped stone. The sun sets behind towers that reach toward the sky, not with the aggressive verticality of steel frame construction, but with the patient permanence of stone, each level supporting the next, the whole structure designed to stand for millennia, because that's the only kind of permanence this civilization knows how to build. You look at your hands again, at the obsidian knife that's sharper than any steel blade, but must be constantly maintained, constantly resharpened, never taken for granted, because fragility is the price of sharpness in a world where durability comes only from mass and care. And you realize that what we call progress, what we measure in terms of GDP and technological capability, is really just one possible expression of human creativity, contingent on resources and accidents of geology that could have been different. The metal-less civilization isn't primitive or backward, it's simply different, built on foundations that led them in other directions, creating beauty and solving problems in ways we never imagined because we never needed to. Their world is quieter than ours, slower in some ways, more careful because every tool costs more to make and more to maintain. But it's also more integrated, more organic, less extractive, and more cyclical. A civilization that learned to work with constraints that would have forced us to find different paths. And standing here in this twilight city of ceramic and wood and stone, you wonder not which world is better, but what it reveals about the nature of civilization itself. That human ingenuity can create wonder from whatever materials the universe provides. That scarcity breeds innovation as surely as abundance, and that the tools we use shape not just what we build, but who we become.